Assalamu alaikum students. Welcome back to online lectures. This week we'll be discussing chapter number 8, which is switching. The first question that is in mind is why we need switching and what is switching. Okay, now let's talk about switching is a topic that can be discussed on several layers. First thing first, there are certain things that need to be briefed. We have switching on a physical layer, we have switching on network layer, we have switching on data link layer, and even logically at application layer as well, which is basically called message switching. We will discuss message switching as well. हम लोग सिर्फ जनरल आइडिया लेंगे स्विचिंग का इस चैप्टर के अंदर. We will not go into details. This is the last chapter where we will be talking about the physical layer. After that we will not be discussing any more physical layer. Basically when we'll be discussing circuit switch, we'll know that circuit switching is basically on physical layer. So after that we will not be discussing any physical layer. We will introduce packet switching as well, which is basically on the second layer, data link layer, and on third layer, that is network layer as well. And finally we'll talk about the structure of the switching devices, which can be a switch itself or a router. This chapter is divided into 4 sections. The first section introduces switching. It mentions 3 methods of switching: circuit switching, packet switching, and message switching. This section will again defines the switching methods that can occur in some layers of the internet model. In second section we'll discuss circuit switch networks, and we will discuss the 3 phases in these type of networks, which is circuit switch and packet switch and message switch. Later again in this lecture we'll discuss about the efficiency of these networks, and we'll discuss about the delays in this type of networks. The third section briefly discuss packet switch networks. First we'll describe datagram networks, listing their characteristics and advantages. The section then describe virtual circuit networks, explaining their features and operations. We will discuss packet switch networks in more detail in chapter number 18. The last section will discuss the structure of the switch. We already know the switching device can be a router or a switch. It first describes the structure of a circuit switch. It then explains the structure of packet switch. Now let's start with topic 8.1, introduction. A network is a set of connected devices. We already know that the set of devices makes the network. Previously we learned that the devices or the network, the devices which are connected to network, the type of networks are point-to-point. We have point-to-point type of network, and then we have another type of network which is basically a multi-point network, where we discussed about the bus topologies, star topologies, ring, tree, and mesh topologies. Now in point-to-point we can see that 2 computers, they are connected together. This is point-to-point, or 2 LANs are connected between using a switches, or we have a point-to-point in which we can see there are 2 routers are connected together. Whereas in multi-point networks we have multiple computers are connected, in which we have multiple lines. Whenever we have multiple devices, we have a problem of how to connect them to make one-to-one communication possible. One solution is to make a point-to-point connection between each pair of devices, like a mesh topology, or between a central device and every other device, a star topology. These methods, however, are impractical and wasteful when applied to a very large network. The number of length of the links require too much infrastructure to be cost efficient, and the majority of these links would be idle most of the time. Other topologies employing multi-point connection, such as a bus, are ruled out because the distance between devices and the total number of devices increase beyond the capacities of the media and the equipment. A better solution is switching. A switch network consists of series of interlinked. So we can see they are interlinks. Nodes called switches. These are all switches. 1, 2, 3, 4, and 5. Switches are devices capable of creating temporary connections. So they will make a temporary connection from here to here, from here to here, a temporary connection. And then it will probably ask the other device for temporary connection, and then we'll make a temporary connection with these devices, and then temporary connection here, and then we can reach to wherever we want to go. Like if we want to go from here to here, right? So it will ask this switch a temporary connection, and once the connection is made, we can communicate. In a switch network, some of these nodes are connected to the end stage systems. So these are connected to the end systems. So you can see they're all connected to some end points or end connections. Others are used only for routing. So these intermediate, they're only used for routing. So if there is some in the middle here, only for routing, they are not connected with the end system. The end systems are basically the communicating devices. So these are the communicating devices. This device can communicate, means initiate a communication with any of these end systems. Like it can want to communicate over here, if it want to communicate over there, it's the same thing. Each switch is connected with multiple links. So this switch it has a link here, it has a link here as well, so it has multiple links. Let's talk about the methods of switching. Traditionally, 3 methods of switching has been discussed. Number 1 is circuit switching. Number 2 is packet switching, and number 3 is called message switching. The first 2 are commonly used today. The third has been phased out in general communication, but still has networking application. Packet switching can further be divided into two subcategories: a virtual circuit and a datagram network. In this chapter, we'll discuss only circuit switch and packet switch. Message switching is more conceptual than practical. We will discuss a little bit, we'll touch on message switching a little bit, but as we already know, this method is already cast out, so it doesn't matter, but we will discuss it. So let's talk about the switching on TCP/IP layer and OSI layer. As you can see, switching can happen at several layers of the TCP/IP protocol. Recap chapter number 2. We know that this is the first layer of TCP/IP called application layer. This is the second layer, which is called transport layer of TCP/IP. This is the third layer of TCP/IP, and then this is the fourth layer called host to network layer of TCP/IP. And we know that these are 7 layers in of OSI as well. So let's talk about switching at the physical layer. We are here. Let's talk about switching at physical layer. At the physical layer, we can have only circuit switching. So the circuit switching goes here, circuit switching goes here. There are no packet exchange at the physical layer. The switches at the physical layer allow signals to travel in one path to another. So this is circuit switching. Now let's talk about switching at data link layer. At a data link layer, this is the data link layer. At data link layer, we can have packet switching. So we can have a packet switching here, packet switching. Okay, we have packet switching here. However, the term packet in this case means frames or cells. Packet switching at the data link layer is normally done using a virtual circuits. So we see here virtual circuits on second layer. Then let's talk about the switching on the third layer. We have, this is the third layer. We'll talk about at network layer we can have packet switching. So we can have again the packet switching over here. But this time in this case either virtual circuit approach or datagram approach can be used. So we can use datagram and virtual circuit both, and over here we can use only virtual circuits if we talk about data link layer, which is like layer 2. Currently the internet uses datagram approach, so this is the one which is being used by the internet. But the tendency is to move to a virtual circuit approaches as well, so we'll probably be moving towards virtual circuit when we talk about internet as well. So let's talk about switching on the application layer. At the application layer, we can have only message switching. The communication at the application layer occurs by exchanging the messages. Means like if you have two different browsers and you are playing video on it, or you are doing some other browsing, so the exchange of messages will be on application layer. Your one browser will receive only one type of messages, and your other browser will definitely receive other type of messages. Conceptually, we can say that communication using an email is a kind of message switch communication. So email is one type of message switch communication. We'll talk about that one later in the lecture. But we do not see any network that actually can be called a message switch network. So there is no actuality behind the message switch. But we say when we talk about message switching, we talk about application layers.